Hi, welcome back to this channel. Today I would like to walk you through um, this paper 2023 May June, variance 2, paper 2, variance 2. Okay, so first question, soft inequalities. Um, okay, a lot of them together. So we have minus 3x, so minus 4, okay, greater than 0, and divided by 3, 4, and we can factorize it. Can we? Yes, we can. X minus 4 greater than 0. So let's sketch the graph of this quadratics, right? The graph of this quadratics is a curve, right? We know that quadratics with positive coefficient of x squared would be a U shape, right? That will cut, since this is a factorized form, right? So we know that it will cut the x-axis at 1 and 4, right? 1 and 4. So this is asking you, right? This solving this inequality is equivalently asking that for what regions or for what interval of x in which each value, when you substitute in, the entire thing will give you an output, right, which is positive, which is greater than 0. So the output is y, so we look at the part where the y coordinate is negative, right? So probably we know that this part, every point on this part of the curve has negative y coordinate. So let's say this point, right, it has negative y coordinate. Okay, negative y. Let's say this point has negative y, right? This point has negative y. So so the corresponding x of every point is here, right? The corresponding domain, the corresponding x of this interval, right, of this part would be x greater than 1, less than 4, right? So within these regions, okay, no matter what you substitute, let's say you take 2 or 3 or 1.5, whatever, as long as it is between 1 and 4, you substitute into this, right, you will get positive, right? So this is the answer, right? 3x squared minus 12x plus 16 in the form of this, completing the square. Okay, so first step, right, we need to, let me copy the questions, factorize factorize the 3 out because the coefficient of x is 1. Sorry. So 3x minus 4, right, 16th. Okay, factorize the 3 out of the first two terms. And then to make this a complete square, right, we need to add the half of 4, which is 2, right, which is 2, into add a square of 2, and to minus it back, right, plus 16th. Okay, so this will complete the square. So we have x minus 2 square, and then this is minus 4 16th, and then expand the brackets, right? So we have 3x minus 2 square minus 12 plus 16th. So therefore we have this thing finally. Okay, so I guess this is the correct answer. Hence, write down the equation of tangent to the curve at the minimum point. So we know that at minimum or maximum, the tangent line must be horizontal, right? Because if you know a little bit about differentiation derivative, you know that at turning point, or we call it stationary point, actually these two are slightly different, but in IG you can think of stationary point as turning point, means maximum or minimum, right? At maximum or minimum point, right, local maximum or local minimum, we have a tangent line which is horizontal, right, which has gradient 0. So this is why to find max or min, if you want to use differentiation methods, we figure out the dy dx and let it to be 0, right, because dy dx represent the gradient of the tangent at any point, right, any point. So since that we know that it's a horizontal line, and horizontal line take this form, right, y equals to k, some number, right, let's say y equals to 1 is a horizontal line that cut the y-axis at 1, right. Let's say I have a y-axis, this is 1, right, I have a horizontal line, then this line is so-called y equals to 1, right, and so on and so on. So y equals to k, right, so we need to determine what the k here. Then what is the minimum point here? The minimum point is, the minimum y value is 4, right, the minimum output of the entire thing is 4, so y equals to 4. So this is why they tell you hence, right, write down without doing any calculations, right, because we know that this curve, right, this curve has a minimum point 2, 4, right, then the tangent line would be y equals to 4, right, y equals to 4. Okay, give me a few seconds. Okay, let's move on. A curve has equations y equals to 32x squared plus 1 over 8x squared, where x is not 0. Okay, find the coordinates of stationary point, right, stationary point. So this is what I just mentioned, right, probably just a minute ago. So dy dx, right, so this would be 64x, and this thing is, be careful, right, this thing is 1 over 8x negative 2, right, and a lot of students make this kind of mistake, right, writing this as 8x negative 2, which is wrong, right. You brought you bring, in this case you bring the x to the numerator, so yes, it becomes negative, but when you bring the 8 on top, right, you also need to have a negative, right, negative, so which is this thing, right. Okay, so so we have 1 over 8x negative 2, so differentiate this thing, we have negative 1 over 4, right, x to the power of 3 on the bottom, because power is negative 3. Okay, so find the coordinates, so let this to be 0, right. Whenever we see denominator in that maths paper, right, you always get rid of it by multiplying the denominator on both sides, right. So 256x4 minus 1 equals 0, right. What I'm doing here is multiplying 4x cubed on both sides. Okay, and yeah, this kind of algebraic manipulation skill you need to be very, very familiar, I would say, in order to succeed in maths, right. You need to have a strong foundation or strong algebraic skill, right, algebra skill that you learn from IGCSE math. Okay, because if you go find your textbook, right, your textbook did mention this kind of technique, right, they'll get rid of the denominator. Okay, so this kind of technique is commonly used in additional maths. So what we have here is x to the power 4 is 1 over 256. So x would be, now when we try to reverse, right, find the inverse function of for even power, we need to put a plus minus root, right, we need to put a plus minus root. Okay, so using a calculator, or if you know that this is 4 to the power 4, then this is 1 to the power 4, then you probably know this is 1 over 4, right, 1 over 4. So coordinates, right, so we need to find the corresponding y coordinate. when, right, so y is what? Y is this thing, right? Oh, because of square, right? Because of square. So the y coordinates would be the same, right? Would be the same. Okay, plus minus, no matter your x is positive 1/4, positive a quarter, or negative a quarter, right? Doesn't matter because after square they are the same, right? Positive or negative after square, they are the same. So this is 2, right? This is 1/16. Okay, this is also, this is 1/16, so 1/2, 1/1/2, right, is 2. So this is 4. So that means the coordinates of two stationary points is 1/4, 4, and negative 1/4, 4. Right. Okay, that's all for these questions. These stationary points have the same nature. Okay, right, use the second derivative test to determine whether they are maximum or minimum. Okay, second derivative, d2y dx squared. Okay, differentiate first derivative one more time. 64, right? This thing is negative 1/4 x to the power of negative 2. Differentiate one more time would be 3/4 x to the power of negative 4. Okay, so when x is 1/4, right, the second derivative just depends on x, so we just need to consider the x coordinates of every point, right? That's enough. Okay, if we move on to A level, whatever, sometimes you need to do some implicit differentiation for some equation given implicitly. Then at that time you might need both x and y coordinate to find the corresponding corresponding value of first and second derivative. But in IG it just depends on x. Okay, so 64 plus this is 3, right? 4 times 1/4 to the power of 3. So this would be 1/4 to the power 1/16 divided by 1/16, so times 16. So 64 plus 48, so which is 112, which is greater than 0, right? The number itself doesn't matter, the magnitude itself doesn't matter, just the sign, right? But it's positive, then we know that it's minimum, right? It's minimum. d2y dx squared equals 64 plus 3, 4 minus negative 4, power of, oh no, this is to the power of 4, make a mistake here. To the power of 4, then this is 64, right? 64, so this is 128, so this is 64. Yeah, to the power of 4, positive or negative, right? They are the same. It's also equals 128 greater than 0, right? So determine, so they are minimum points. Show that x plus 3 is a factor of this polynomial. Okay, so we just substitute x equals to negative 3, the value. How do we know substitute what value, right? You let it to be 0 and solve it, we know that x equals to negative 3. So negative 12 plus 23 times negative 3 plus 3 times negative 3, 3 times negative 3 squared minus 2 times negative 3 to the power of 3. So this is 69, this is 27, this is positive 54, so it's 81, yeah, 0. Okay. Just need to prove that the result is 0 is good enough. Yeah. Okay, let's see. oh no, this is square root, no, this is square root, I made a mistake here. This is fourth root, not square root, right? Fourth root. Okay, so it should be fourth root, right? Not square root. Yeah, should be correct. Okay. The curve y equals to negative 5 plus 33x plus 3x squared minus 2x cubed, and a line intersect at 3 points. Okay. A, B, C. These points are such that x coordinate of A has the least value. X coordinate means that because they tell you the intersect at 3, and A, B, C, if they don't tell you this second sentence, right, they didn't mention this second sentence, maybe A can be here, right, B can be here, C can be here, who knows, right, C, A, B, whatever. But the second sentence is telling us that A is the first intersection point, right, from the left. Okay, look from the left to right. A is here, B is here, and C is here, right? C is here. And show that B is the midpoint of AC, right? B is the midpoint of AC. Okay, let's take a look. So we substitute this, right, into the y here. So we have equal negative 5 plus 33x plus 3x squared minus 2x cubed. So make the highest power term with positive coefficients, right? Oh, no need, because look at this, right? It's probably quite similar. So we have negative 12, okay, move to negative 12, and minus 10, so it's plus 23x plus squared minus 2x cubed equals 0. And then this is already giving us a hint, right? This is giving us a hint that this has a x plus 3 factor, right? This has an x plus 3 factor. So do a long divisions, put the highest power term in front, followed by square power, and then power 1, and then power 0. Alright, so this would be negative 2x squared, so negative 2x cubed minus 6x squared. So minus negative is plus, so this would be plus 6, so it's 9x squared plus 23x, so plus 9x, 9x times x, 9x squared, 9x times 3, 27x. Okay, so we have 4x minus 12. Yes, beautiful. Times 4, right? 4x, oh wait, this is negative. X plus 3 is a factor. Then I should have a negative. Yeah, I should have a negative here. Yes. So it should be negative. Okay, this is 0, right? Remain as 0, so which means that we can write it as x plus 3 times negative 2x squared plus 9x minus 4 equals 0, right? For the sake of convenience, to conveniently factorize it, right? So we make the coefficient of x squared to be positive, right, by factorize the negative out and then divide negative on both sides of the equations, right? So can we factorize this thing? Yeah, probably, right? So x, 2x, then 4, 1, then minus. So we have 1 is x equals to, the smallest one would be negative 3, right? And then 1, and then 4. Okay, so which means that, right? So the corresponding y coordinate would be 10 times x plus 7. So 10 times x plus 7, so negative 23. So this is A, right? A is on the leftmost, right? It's the leftmost point. -3, -23. Just the x-coordinate is not enough, right? Because if you want to prove that is the midpoint of some other 2 points, you need to prove x is in the middle of the x-coordinate of other 2 points, and also y. The y coordinate of the midpoint is also in the middle of the y coordinate of the other 2 points. So yeah, it's not very hard, but it's just a bit troublesome, right? You write a lot of things. 17th b would be 1/17, and this one 10 times 4 plus 7, so it's 47. So c would be 447. So let's see, right? So midpoint of AC, right? Midpoint of AC would be x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's see, -3rd, so this would be 1/2. All right, no one, this is not 1, right? This is 1/2. In the mistake here. 1/2, 5 is 12. Okay, and then this would be what? 47 minus 23 will be 24 divided by 2. Yes, indeed 12, right? Which is B, right? Which is B. Yeah, we prove that it is indeed B, right? It's indeed B. Variables x and y are related by the equations y equals to 2 plus tangent 1 minus x, where x is within the first quadrant. Given that x is increasing, so this kind of questions, right, we need to be able to translate it into some mathematical expression, or we need to use mathematical language, right, to transform the sentence from English words to mathematical equations, right? So this means that, right, x is increasing. This is a rate of change of x, so this is dx dt, 0.04. Find the rate of change of y, so they're asking for dy dt. Okay, when y equals 3, right? So first of all, dy dt would be dy over dt, so dx, okay, right, dy dt, these to cancel. Actually this equals to this, right? Dx dt is given, but dy dx, so to find out dy dx, differentiate 2 is 0, differentiate tangent is secant square, 1 minus x. By chain rule, we need to multiply an additional negative, right? Derivative of this thing is -1. So when y equals 3, but dy dx is depends on x, so you find the corresponding x, right, when y equals 3. 3 would equal to 2 plus tangent 1 minus x. So we have tangent 1 minus x should be 1. Tangent in first quadrant for pi over 4, right? Pi over 4. So 1 minus x should be pi over 4. Right? It could be first or third quadrant, but question restricted in first quadrant, so we use first quadrant angle. So x would be 1 minus pi over 4, right? So which is 4 minus pi over 4. So this is 4 minus pi over 4 times 0.04, right? 0.04. So this is 4 over 100, so it would be 4 minus pi over 100. Yeah, so I guess this is the answer. You can write it in decimal form, doesn't matter, I guess. You can use your calculator and give the decimal answer. Alright, so right, so let's take a look what should the decimal answer of this should be. 4 minus pi, and then divided by 100. So it's roughly 0.0085, right? 0.0086, yeah, something like that. Okay, so yeah, 0.0086, right? 0.086, 858. All right, let's look at next questions. Variable p and t are known to be connected by the relationship p equals to a times b to the power of t, where a and b are constants. Values of p are found for certain values of time t. Show that a graph of log p again will be a straight line. Now we need to take log on both sides, right? Lg without the o and without the base. This means by default it is base 10. So we take log on both sides of this equation. So Lg, right? Log p equals to log a bt. Okay, so we know that this is the relationship between b to the power of t and a, right? Is times. So times means you can write it as log a plus log bt. Okay, so log p, the t we can put it in front, right? So it would be log b, t times log b means log b times t, right? And then plus log a. Okay, so this would be our y equals to m, right? X plus c, right? mx plus c. Okay, so indeed it's a straight line, right? It's a straight line, okay. So the diagram shows the graph passes through 0, 6 and find the value of a and b. Okay, so log b is the m, right? So log b is m, gradient. Gradient, it would be y2 minus y1 divided by x2 minus x1. So it is 6 over 14th, right? So b would be equals to 10 to the power of 6 over 14, right? So this would be, what is this? 10 to the power of 6 over 14. So this is 3 significant figures, 2.68. And yes. All right. How about B? How about A? A would be the log A would be the C, right? Log A would be the C. C is the y-intercept. Yeah, this is the y-intercept, right? You know that y-intercept has 0 x-coordinate, so 6, be 10 to the power of 6, right? A million. Right, okay. So using the graph of or otherwise find the length of time for which p is between 100 millions to 1000 millions, right? Let's see, p, what is the unit of p? Values of p, right, is connected, so there's no unit for p, right? So using the graph or otherwise, so you either use the graph or use some algebra or whatever. Find the length of time for which p is between 100 million. P is 100 million. Okay, p is 100 million means log p, right? Log p would be log 100 million. Million is 10 to the power 6, so 10 to the power 8, right? So which is 8. Okay, so using the graph, we have 8. No, log p is 8. It should be here. Okay, not should be the y coordinate should be 8, not the x coordinate. Log p is 8. Seems like here, right? Seems like 4.45, something like that. Yeah, 4.35, right? 4.35. 4.35. 35, yes, 4.35. Okay, so 4.35t, right? 4.35t. Let me see, use the graph or otherwise. Log p1 should be, oh no, it's not 4.35, is it? This is 6, not 5. 6, then this is 5, right? Middle is 5. Then 4.2, 4.4, 4.6, 4.8, 4.7, right? 4.7. Okay, so 4.7, right? It's between 100 million to 1000 million. 1000 million means 10 to the power of 9, right? 10 to the power of 9. 9 would be middle here. So it would be 6.8, 6.9, right? 6.8, 6.9. So it is T1, T2 equals 6.9. So the length of time, it would be 6.9 minus 4 so the delta T, right? Difference in time, so it's 2.2. Okay, 2.2. Alright, so yeah, 6.9, I guess. Yeah. Oh no. I mean, it should be 6.9, is it? It seems like it should be exactly 7, right? It should be exactly 7. So 7, 7.0. 7.0. 2.3? Okay, 2.3. Alright, so find the first three terms in the expansions of this to the power of 5 in ascending powers of x. Simplify the coefficients. Okay, so this is straightforward, right? Just apply the formula and simplify it. That's it. So this means that we have 5 brackets of this thing, right? Multiplying together with each other. How many ways of taking one on from each bracket, right? Every bracket have 2 terms, 1 and x over 7. So the way to form 1 to the power of 5 is only one way, right? It's only one way, which is 1. 1 to the power of 1 to any power is 1, right? So of course 1 to the power of 5 is still 1. And instead of taking first term for all brackets from each of these brackets, out of 5 brackets, 4 brackets I take 1, the remaining 1 bracket I take x over 7, right? And then how many ways of getting this done, right? It would be out of 5, choose 1, right? Okay, because you can refer to the formula booklet, right? But this is what I'm explaining, what I'm talking about is the idea behind the formula, right? The idea behind the formula. So other way, we can take 3 brackets, we take 1, right? Multiply all them together, and then the remaining 2 brackets, I take the second term. How many ways of getting this done? 5, choose 2, right? If you write 5 choose 3, doesn't matter, right? 5 choose 2 equals to 5 choose 3. This is not coincident, right? N choose R equals to NC n minus R. This is not coincident, right? This is not coincident. Because you're choosing R out of N means that I'm choosing the remaining item, right? After you have chosen R item out of N, then N minus R is the remaining item, right? It's same as you are putting the remaining item aside, right? Then that is one way, right, of choosing. So how many, this is a 1-to-1 corresponding, right? How many ways here is how many ways here. But that's not important, right? As long as you know how to apply the formulas, that's it. Okay, just for students who are strong at maths, right? Want to know more about this kind of thing. Okay, so x over 7, 3 plus first three terms, right? 1, 2, 3. I guess that's it. First three terms plus dot dot dot, right? Okay, so ones, 5 choose 1 is 5, 1 to the power 4 is 1, so this is 5 over 7x. This is 5 choose 2 would be 10, right? 10, 10 times 1 is 10. This is 10 over 49 x squared plus dot dot. Okay. The expansion of this whole thing, where the third term, the second bracket is this what we have done here, where n is a positive integers, is written in ascending power, right? So the first two terms in the ascending power is this, find the value of n. Okay, so let's try to expand this thing first, right? So this would be 1 to the power of n, right? Each of n brackets, I take the first term and multiply them all together. 1 to the power of n, right, plus 1 to the power of n minus 1, right? Because if you try to observe the pattern, the power is decreasing one by one, right? This thing you can view it as 5, 0, right? 1 to the power of 5, x over 7 to the power of 0, right? If you observe the power is increased 1 by 1, right? 0, 1, 2, the power of second term. The power of first term is decreasing 1 by 1, right? And so on. And this is 5 CR, right? 5 CR, so on and so on. Okay, so let's see, and choose 1, and then the second term I choose 1, right? So the so we have n choose one way of doing this, getting this done, right? Is 2 term enough? I guess 2 terms are enough, right? 2 terms, there's only x term, right? Only x term. If the next term will be x squared term, it won't contribute to this 89x because the power of x here, they are all non-negative, right? They are positive. So yeah, the second term is enough. Plus dot dot dot. 1 to any power is 1. N choose 1, we have n ways. 1 to any power is 1, so nx plus dot dot dot. So 7 times 1 plus x to the power of n, 1 plus x to the power of 7 to the power of 5, it can be written as 7 times, just write it in, times what we got just now, 1 plus 5 over 7x plus 10 over 49x squared plus dot dot dot. Okay, so in expansion of an entire thing, right, if you multiply all the constant term, yes, you get this, correct? So in order to get the x term, right, how many ways of doing this? Right, this is the first way, 7 times 1, right, times the x term here. And the second way is 7 times nx times 1 here, right? Okay, so this would be the blue one. The blue one would be 7 times 1 times 5 over 7x plus the black triangle, 7 times nx times 1 would equals to 89x. So this is 5x plus 7nx equals to 89x. So 7n would be minus 584. So n would equals to 12. Perfect. Okay, so yeah. In the expansions of k minus 2x to the power of 8, where k is a constant, the coefficient of x to the power of 4 is divided by the coefficient. Okay, it's coefficient divided by coefficient of two different terms. One is x to the power of 4 term, one is x to the power of 2 term. The coefficient of x is positive. Okay, form an equation and hence. Okay, let's expand this thing first. Actually, we don't need to expand. We just need to take a look at x to the power 4. To get x to the power 4, right? This means we have 8 brackets, right? 1 2 3 4 5 6 7 8. Okay. I need to, out of 8 brackets, 4 out of 8 brackets, I need to take the second term, right? Only the second term will contribute to the power of x, because the first term doesn't contain any x, right? So to get the x to the power 4 is second term 4, right? Out of 8 bracket I take 4, and the remaining 4 bracket I take k. How many way of doing this? It is out of 8 choose 4. So let's see, right? So this would be 8 choose 4. What is this? 8 choose 4. 70. So 70k, this is 16, right? 70 times 16. So 1120 k to the power 4, x to the power 4. And then x squared means that's the second term. Out of 8 brackets, 2 brackets I take the second term, then the remaining 6 brackets I take the first term. How many way of getting this done? It choose 2 or it choose 6, doesn't matter, right? It choose 2, no, it's C2, 28 times 4, so it's 112 k6 x squared. So it tells us the ratio, right? The ratio divided is ratio. So the coefficients ratio, right, is 8/5. So 1120k4 divided by 112 k to the power of 6 should equals to ratio 5 to 8. Okay, exactly 10. So we have 10 k squared equals to 5/8. Divided by 5 is 1, divided by 5 is 2. So k squared would equal to 16, so k should equals to plus minus square root 16, which is 4. But the coefficient of x is positive, right? The coefficient of x is positive. So in order to get x, you need to have something like this, right? To the power of 1 and k to the power of 7, right? And then h is 1. Okay, they tell us that this is positive, right? It's positive. It's greater than 0. So we know that this is positive, and then we know that the coefficient, right? The coefficient. So this is negative. In order to get positive, my k to the power 7 need to be negative, right? Need to be negative. So my k need to be negative. Okay, so rejected the positive solutions, right? Okay, sometimes they tell you something, some extra sentence that you might first thought that first thing that it is useless information. Actually, sometimes it's telling you something, right? It's asking you to choose the correct answer according to the information given, right? All right. So yes. Fx equals to square root this thing where x greater than 1, find expression for f prime x, right? So f prime means derivative, right? Derivative, first derivative is let's write this thing in the power of 1/2 3 plus 4x minus 2 power of 5. So first of all, right, we need to apply the chain rule. We need to differentiate the outest function, right? The one that is the outest one. So 1/2, right? And then inside remain unchanged, right? And then power minus 1, which is negative 1/2, right? Okay, to make things more clear, clearer, right? Use a different bracket. Times, right? The derivative of the thing inside, right? Derivative of 3 is 0. Derivative of this thing is, pull the 5 in front. Inside remain unchanged, 5 minus 1, 4. And derivative of this thing is 4. So finally we have 4 times 5, 20. 20 divided by 2 is 10. 10 is negative power, so square root on the bottom and positive power on top. Yeah, so we are done, right? Giving your answer as a simplified, yeah, I guess this is simplified form. Okay, variables x and y are related by the equations. Using differentiations, find approximate change, right? Approximate change delta x, right? Delta x when the delta y, right? When the delta y is 0.01, right, at 10. Because dy dx differentiation is about instantaneous rate of change, right? Okay, so let's see. We know that delta y over delta x, this is the approximate change, the average rate of change. This is not instantaneous rate of change. This average rate of change is approximately equals to instantaneous rate of change only when the delta x is small, right? Only when the delta x is small. Otherwise, they are not even approximate, right? Delta x, delta y is 0.01. Okay, so 0.01. So they are asking for the delta x. So what is dy dx? Dy dx, this one, to make things easier, you can do the long division first, right? Or directly apply the quotient rule, right? Quotient rule is denominator times the derivative of numerator minus numerator times the derivative of denominator divided by denominator square. So this is 15x plus 10 minus 15x. So 15 minus 15x cancelled, right? It's 10. This would be 2. Okay. So this is when y, this is delta y. This is at y equals to 0. Y equals to 10. But our dy dx depend on x. So when, right, y equals to 10, what is the corresponding x? Right, let's solve for it. 30x plus 20 equals to 5x. Okay, 25x equals to negative 20. So x equals to negative 4 over 5. So which is 0.8, right? Negative 0.8. So dy dx, right, when x equals to negative 0.8, dy dx would equal to 10 over 3 times 0.8 plus 2 square, right? So 2.4, this is negative, right? Negative 2.4. Negative 2.4 plus 2, so it's negative 0.4. Negative 0.4 to the power of 2, it would be 0.16, right? 10 divided by 0.16. 62.5, right? 62.5. Is approximately equals to 62.5. Okay, so delta x is, these two can swap their positions, right? 0.01 over 62.5. This is 1 over 100. So it's 1 over 6250. Okay, yeah, that's all. differentiate this thing, we need to use the product rule, right? dy dx will equals to the first functions times the derivative of second functions plus the second functions times derivative of third function, first functions, x squared plus 3x squared ln x. Okay, hence, okay, this means that we need to use the result from part 1. If we try to see that, you need to try to observe, right, what is the similarity and the differences between what you arrive at from the previous sections and what you're given in these sections, right? So x squared, this is 1 plus 3 ln x. Okay, so x squared. Okay, now the difference is this is 1, but this is 2, right? And a lot of students will say, easy, right? Factorize the 2 out. So if you factorize the 2 out, it becomes x squared divided by 3, 1 plus. But this you also become 3 over 2, right? Now here is the same, but here is not the same. So you times or multiply, times or divide, right? A number doesn't work here, right? Times and divide some number, this works, right, for this kind of, this work for this kind of question most of the time, but this question is an exception, right? Times and divide doesn't work because no matter you times and divide, this entire thing is together, right? Both terms will change. So only distant change, so we try to only do this thing, right? Do this thing, 1 plus 1. I factorize a 1 plus 3, right? 1 plus 3 ln x out. Okay. This is the only way, right, I guess, to do this, right? Without changing the 3 ln x, but we can change the 2 to 1, right? We can change the 2 to 1. Okay, so we have this times this, right? We have integrate x squared 6 dx plus integrate x squared over 6. Over 6, I can take it out, become 1 over 6 x squared times 1 plus, right? Times 1 plus 3 ln x. Okay, now finally, right, we have separated out something that is exactly same as what we did here, right? So integrate this thing would be this thing, right? Would be the one given in part C1. So integrate this, it would be x cubed divided by 18, right? And then plus 1 over 6 times x cubed ln x plus c. Okay, so we have x cubed over 18 and then x cubed ln x over 6 plus c. All right. Yes, yeah. This could be good. Okay, a curve has equation y equals to cosine x over 4 as x is in radians. The normal to the curve at the point where x equals to 4 pi over 3 cuts the x-axis at the point P means that we have a curve. Okay, the curve at the point somewhere, let's simply choose a point, let's say here, right? So the tangent lines, okay, no, it's not tangent line, normal lines, right? Normal line cuts the x-axis, right? The normal line at 4 pi over 3 cut the x-axis, right? Cut the x-axis at P, right? Find this thing, right? Find this thing. Okay, so first of all, right, you need to find the equation of this line, and then we need to and then find the x-intercept of this line, right? Point P is the x-intercept. Okay, so dy dx differentiate cosine, we get negative sine. Inside, just copy it, but we need to further multiply with We need to multiply an extra derivative of x over 4, which is 1 over 4, right? Okay, a common pitfall here is that a lot of students will write 4 here, which is wrong, right? X over 4 differentiate, right? Differentiate 4x is 4, yes, but differentiate x over 4, this is this, right? 1 over 4. So we need to multiply an additional 1 over 4. And cuts dy x, dy dx. Okay. So at this point, right, at x equals to 4 pi over 3, the gradient, right, this is the gradient of the tangent lines, will be negative 1 over 4 sine 4 pi over 3 over 4. So it is pi over 3. This is 180 divided by 360. Sine 60 is square root 3 over 2. Right, it's negative square root 3 over 8. Okay, so this is the gradient of tangent. So the gradient of the normal would be, right? So the gradient of the normal would be negative reciprocal, right? Negative reciprocal. Okay, so to make things more clearly, right, this is normal. And so we know the gradient of this line, and we need to know this point, right? So when x equals to 4 pi over 3, we need to substitute into the curves to find the y coordinate of this point, right? So y would be cosine 4 pi over 3 over 4, so pi over 3. So cosine 60 is 1 over 2. Okay, so which means that the normal point, right? The normal point is this. This is this point. Okay, so so the equation would be y minus y1 equals to the gradient. Oh no, sorry. This is the x. X is 4 pi over 3, right? So y minus y1 equals to m times x minus x1. Because if I'm using this equation, this line equation, of course, I guess more than 90% of students are more familiar with y equals mx plus c. You can also do so. Find p. P is x intercept. X intercept we substitute 0, right? Substitute 0 inside. So times set 3 on both sides. Times 2 set 3 on both sides. Times 2 set 3 on both sides to get rid of. No, times 6 set 3 on both sides, right? Times 6 set 3 on both sides to get rid of all the denominator. So negative 3 set 3. So 6 set 3, 48. X. And then 6 set 3. 6 set 3, 48. Divided by 3 is 48. 16th. 16th. 6 3 648. So it's 16th. No, this is 64, right? This is 64 pi, right? We times 6 3 on both sides, right? Times 6 3 on both sides. Yes. Okay, so x would equals to 64 pi minus 3 set 3 over 48. Yeah, I guess this would be the x coordinate of the point P, right? Find the exact coordinate of point P. Okay, find the exact coordinate of point P. Yeah. Okay, so let's see. What is the y coordinate? The y coordinate of this point would be 0, right? 0 because x-intercept. So 64 pi minus 3 set 3 over 48, 0. Okay. A particle travels in a straight line so that t seconds after passing a fixed point, its velocity v meter per second is given by this. Okay, for the first 4 seconds is this, for the next k minus 4 seconds is this. Okay, so the total distance traveled, this distance, right, between t equals 0 and t equals to k is 13.4. Now distance and displacement is not the same. If you directly integrate this thing, what you get is displacement, right? Displacement. But in one situation, under one situation, displacement and distance, they would be the same under one specific situation. That situation is that when, right, the particle has never changed the direction for the entire journey, then displacement and time is the same, right? Displacement and distance are the same. Displacement and distance are different. They only differ, right, when it changed directions, right? When it had ever changed directions, right? Okay, so let's see, right? This thing, right? E to the power t over 4, right? Your base is positive no matter what your power is. This is greater than 0, right? More specifically, in this region is positive, right? And then 16e t squared is positive, e is positive, right? So this thing is on top is non-negative, so it's also greater than 0, right? No matter what your t is, right? So we know that velocity is always positive. Means what? They is always at the same direction, right? Always going to the right. If you define to the right, it's positive, or if you define to the left, it's positive, then it's always going to the left. It's never change direction. Never change direction, then total distance is easy, right? Just directly integrate. Integrate 0 to 4, right? The first 4 seconds, the distance travel is integrate the first function from 0 to 4 dt plus t equals to k, right? T equals to k. So from 4 to k, 16e t squared dt. The question tells us that this total distance is 13.4. So integrate e to the power of x is still e to the power of x, but we need to divide it by the derivative of this thing. So it's divided by 1 over 4 means times 4, right? Divided by 1 over 2 means times 2. So 4, 0 plus, this is just a number, right? 16e is just a number. So this is just t to the power negative 2. Integrate t to the power negative 2, it become t to the power negative 1, but negative, right? K4. Okay. Yes. All right, so equals to 13 over 4. So substitute 4 inside. 4 over 4 is 1, right? It's 4 over 4 is 1. It's 4e minus, substitute 0 inside, minus 4 plus, this is negative, right? Negative 16k over 16e over k, minus negative, so it's plus 16e over 4. Okay, so times 4k on both 16e over 4, so this would be 4e, right? It would be 4e. So times k on both sides, wait, this would be 8e, and then plus 4, right? So it would be 17 over 0.4. So times k on both sides, or we can factorize the 8e out, right? Minus 2 over k, 17 over 4. So 1 minus 2 over k is 17 over 4 over 8e, right? So 2 over k, which is 1 minus this thing, right? So k would be 1 minus 17 over 4. 1 minus 17.4 divided by 8e divided by no, it is 2 divided by this thing, right? This is 2 divided by this thing. Okay, so, and then just use your calculator, right? Just use calculator, find the value of k. So what is this? Syntax error. So it's 10 point, it's roughly 10, right? 10.006. Okay, yeah. Number 10, the diagram shows a triangle OAB. The point C is the midpoint of OA, so this equals this, right? 1 to 1, okay. The ratio is 1 to 1. The point D lies on CB such that CD to DB is 2 to 3, okay. So OC is C, OCB is B, right? This is C, CB is B, right? CB is B. Okay, C to B. For the point E lies on AB, okay, such that OE is lambda OD, right? So OE is lambda, this lambda probably greater than 1, right? Because OE is longer than OD, right? So probably greater than 1. AE equals to mu AB, AE equals to mu AB. So this mu probably less than 1, right? Because AE is shorter than AB, right? And lambda mu are scalar. Find two expression for OE, each in terms of BC, okay, hence AE, okay. So OE, right, we start from here, we can find the first expressions for OE. So OD is what? OD, we can go, OD is equivalent to OC, right, plus CD. And OC given by question is small c, right? And CD given by questions is 2 over 5 CB, right? It's 2 over 5 CB. 2 over 5 CB, right? 2 over 5 CB. And CB is what? CB is small b, right? Both, in both, right? Both b. And then, yeah, we are successfully with b and c and scalar, yes, okay. Then the second expression from here, AE equals to mu AB. They asked us for OE. So here we don't have OE, right? But we have AE instead. So we can try to separate out the OE, right? Any vector is the position vector of ending point E minus the position vector of starting point A, right? AB is what? A to B. A to B is AC plus CB, right? OE, so OA is what? OA is OA would be, this OC is C, right? So OA would be double, right? So would be 2C. This would be mu. AC would be negative C, right? Going in this direction. Okay, it's negative. Okay, and then CB is B, right? So OE what equals to mu, right? B minus C, right? B minus C plus 2C. Okay, so we can rearrange. Okay, so let's see, AE to EB, right? Hence, so we have done the first part, AE to EB, AE to EB. AE to EB is, we need to find the mu here, right? Solve out the mu, then we can solve for the EB. So lambda C plus 2 over 5B would equals to mu B minus C plus 2C. So I have lambda C plus 2 lambda over 5b would equals to 2 minus mu c plus mu b. So the coefficient of c should equal, the coefficient of b should equal. So lambda equals to 2 minus mu, and 2 lambda over 5 should equals to mu. Yeah, substitute this thing inside. Okay, so we have lambda equals to 2 minus 2 lambda over 5 times 5 on both sides. So we have 7 lambda equals to 10, so lambda equals to 10 over 7. Yeah, it's greater than 1, right? Lambda should greater than 1. Your numerator greater than denominator is 1. It's greater than 1, right? So probably perfect, right? Beautiful result. And what is the mu? So mu would be 2 times lambda over 5. So it would be 20 divided by 5. So it's 4 over 7, right? So mu is 4 over 7. So which means that AE, right? AE is 4 over 7 AB. So which means that, right, AE to AE, length AE ratio to EB equals to 4 to 3, right? 4 over 7, so this is 3, right? 4 to 3. Okay, I guess this is something easy, right? 4 to 3. Yeah, so that's all for this paper, right? So I hope you have some takeaway, right, from this video. Okay, so see you next time. Bye.